Hello everyone, welcome to our channel Wisdom ML. And first of all, if you are new to our channel, so please subscribe to our channel so that whatever new videos and new series we will be uploading, you will get the notification of it. And if you like this video, kindly like our video and do comment whatever your suggestions, whatever you feel. So let's start today's video. So in this project, actually, what we'll be doing is this project is towards the domain of cybersecurity, and in this we'll be developing a malicious URL detection model using machine learning, and we'll be seeing how we can detect automatically the malicious URLs. Malicious means the URLs which are compromised by hackers or used for cyber crimes or cyber attacks, and there are certain types of malicious URL we'll be discussing of it. So let's start today's. So before moving towards malicious URL, we have to first understand that what is URL. So URL is basically a uniform resource locator. It is a unique address by which we can identify a resource in the internet, right? So as you can see, this is a diagrammatic view of what is URL. So let me point out. So as you can see, the URL is divided into three main parts. First is the protocol, right? First is the protocol, which is you can say protocol identifier. It is known as protocol identifier. Second is the host name, right? What is the host name, whether it is google.com, twitter.com, facebook.com, right? So whatever the host name is, and then there is, in the end, there is a path, which is the exact address particular page of website. Right? So this will give the idea that in this website, at what particular path the resource is actually uh, presently exist in this website. So it consists of complete address of a particular resource. Now, one by one, we'll see what is this protocol identifier. So protocol identifier is something that what protocol is using for accessing this a particular website. Because for every protocol, every website should follow a protocol, and there are generally two types of it. One is HTTP, and the other one you all know that is HTTPS, right? Hypertext Transfer Protocol, secure. And mostly you can see that nowadays mostly websites or URLs have HTTPS as the protocol, and you can see there is also a check mark, or you can say uh, lock sign is there, which identifies that the URL or the website which you are looking for is secure, right? So this is very important feature of a very secure URL. Right? So by just only seeing this part, you can get the idea that this site is secure or not secure. Second part is the host name. So host name consists of two basically things. First is the primary domain. So primary domain is the main domain name, that is Google, right, in this case. And top level domain is something what it is, whether it is com or whether it is, let's say, country specific like .in for India, like edu, like for education, org. So what is the top level domain? So top level domain is something like this, right? Just after the primary domain. Next comes the path, which is the exact path of the website. So this is the overall structure of a particular URL. And we all know that every domain name is actually internally mapped to a IP address, right? So most of the time, malicious URL also consists of only IP addresses. So we should be very careful while visiting these types of website, because only IP address based website are mostly traps or malicious websites. So now comes to the part, what is the malicious URL? So as I told you, that compromised URLs, websites that are used by hackers for different types of cyber attacks, cyber crimes, for hacking a particular person's account, is known as malicious URLs. So what? So this is just a basic definition of it. But now, what this malicious URL consists of? So malicious URL consists of different variety of unsolicited content, right? What do you mean by unsolicited? That is, you can say harmful content like spam. Spam is somewhat less harmful, but still it's irritating, because if anyone continuously uh, emailing you, right, and just want to uh, present you a particular idea and want to just overload your website or email account. So that type of things are mostly spams, right? Phishing is something that is uh, the mails which says that you won a big lottery, okay, and your credit card is expired, so you have to enter some personal information like credit card pins, your personal details, addresses, and by that they steal your information and basically fish you in trapping you basically in getting your details. Okay. Next comes another type of attacks is the drive-by downloads. These type of attacks are basically uh, when you visit a particular URL, a malicious software, or you can say malware, will be downloaded automatically, and you will not going to do that. Okay, so you will not know, but in the background, this will be downloaded, and it will uh, do lots of notorious things in your system, right? It will install Trojan, it will try to hack your accounts, okay, steal your information. So this is the thing. Next comes the social engineering. So social engineering something, such type of URLs, when you visit it, all your information like your social media accounts, by getting information from your social media accounts, whatever networks you have, everything, these type of attacks will try to know about yours. Next comes the again these malicious URLs also comes with monetary loss, that I told you that if you visit a URL, they ask you certain very sensitive informations, right? Like credit card details, payment details, your bank account, and in that way it will uh, cost you a big amount, hefty amount. Right? Next is the sometimes identity theft also. Okay, so they steal your identity, your ID card details, and everything, and pretend it as a different user by stealing your ID. So these types of attacks actually, these types of different types of attacks generally uh, present in malicious URLs, and these types of URLs basically the target of making these types of URL is to steal information or to a cyber attack. So what is this project is all about? So in this project, we will be building machine learning models, okay, using lexical features for detecting malicious URLs. And here, apart from lexical features, we'll also be using some content-based features, like whether the website is indexed on Google or not, right? So if the site is indexed in Google, then mostly the sites considered as safe. But nowadays, hackers are getting very smart, and they when they create any URL, hacking URL or malicious URL, they also used to index in the Google Google search also. So, but still, we'll find out that how this feature will help us. So, like that, what is the length of the URL, right? URL length, top level domain length, right? First directory length. So, these types of things which are dependent on the URL features are lexical features. Apart from that, we'll also be seeing the content features, and we'll create different features from the URLs, and we'll try to build a machine learning model on top of that. The dataset used in this project is malicious URL dataset, and it is present on Kaggle, right? So what this dataset is? So this dataset is consist of 6,51,191 URLs. Okay, and the distribution is something like this. So we have majority of benign URLs or safe URLs. Okay, so that the model will learn accurately what considered as safe. Now comes the defacement URLs, which are around 96,000, phishing URLs, which are 94,000 URLs, and malwares are somewhat 32,520 URLs. So let's see how we can build these types of model, right? So we'll quickly move to the Jupyter notebook and see, and we'll see how we can build a model, how we can build the features, and we'll do some uh, exploratory data analysis, right? So now we move towards our Jupyter notebook, where we'll be giving the walkthrough of the whole code for building malicious URL detection model. So let me zoom in a bit so that you can see the code clearly. So first of all, we are importing some important libraries like pandas, very important because we'll be building our model based on pandas data frame. Next, we are also importing classification report, confusion matrix, and accuracy score. These are some model evaluation techniques and methods. Next, for the interest split, and then we are using three models, basically XGBoost, LightGBM, and random forest. And we'll also be plotting some graphs and plots and word clouds also to get the understanding of the distribution of a particular class. So first of all, we are reading our data set. So this is our data set. As you can see that it has around 6,51,191 records, or you can say raw URLs. And we have two columns only. One is the raw URL, okay, and the second is the type. So which type it belongs to. And if you see the distribution, so we have benign or safe URLs, more examples, that is 4,28,000. Whereas defacement, phishing, and malwares have 96, 94, and 32,000 URLs respectively. So as we understand the basic data set, how it looks like and what's the sample data. So now we should understand that in each of the category of malicious URLs, what is the distribution of different keywords. So for that, we should have to plot a word cloud. Okay. So what we are doing is basically we are subsetting our data frame in terms of only phishing records, malware record, defacement, and benign URLs. And then we are plotting the word clouds. So now what we have done is basically we have created four subsets of the data frame based on the classes, and now we are plotting the phishing URL word cloud. So as you can see here, we have certain important frequency words. So if you don't know what is word cloud, so in word cloud, what basically we do, we try to plot all the keywords present in the actual text which we'll be using for building the NLP model. So here the size of the keywords will be larger if they have a higher frequency in the data. So you can see that in phishing, we have STM, HTML, IETF, ORG, HTML, HTTPS. So the reason for these keywords are basically why, because HTML, STM, and ORG, HTML is highest. The reason is that because phishing URL try to mimic the original sites, so their URL also looks like similar to original website. So that's why the keywords are very frequent, like HTML, ORG, and HTML. Next, if we see the malware URL, so as we know that what is malware? Malware try to install some Trojan horse viruses and all. So you can see that Mozi, EXE, B4, E7, BB, E8. So these types of extensions are pretty frequent in malware units, which is the obvious case, right? So next is our defacement URL. So defacement that I told you, that what is defacement URL is something which try to modify the original website by using web development techniques. Okay, to deface the actual owner of the website. So you can see that here some of the development keywords are visible, like index, PHP, and option, article ID. So these are more towards modification of the original website. And last is our safe URLs, that is benign URLs, and that is pretty ways that we have some good renowned websites name, like Wikipedia, Facebook, ORG, HTML, YouTube, right? So Blogspot. So this it clears our understanding that what is the distribution of data and whether each category of URL have means concerned and related keywords or not, for to which category it belongs. So this is the word cloud of all the URLs. Now we'll be move towards feature engineering, and here we'll be creating different lexical features from raw URLs so that we can use those features for building our machine learning. So first feature is something having IP address, that whether the raw URL is containing any IP address or not. So here what we have done, we have given all the variations of IPv4 address. You can see that this is just a regex pattern, regular expression pattern for that. Second is IPv4 in hexadecimal format. These two are pretty common IP addresses, whereas IPv6 is also now common nowadays. So that's why IPv6 we have also given. So these three combinations we have given for getting the pattern if the URL contains IP address. So we have created this function so that we can apply it using lambda function towards the raw URL, and we are making another column name, new column name, that is use of IP. So the reason for building these types of function is that during prediction phase, right, when we used to predict our model, so we have to actually create all the features out of the raw URLs and then feed those features into our machine learning model to get the prediction. So that's why for each of the feature we have to create the functions which we later call in the main function, so to get the prediction. Second is our abnormal URL. Okay, so abnormal URL is basically having a different type of keywords, or it is not normally be seen in the particular URLs. So here what we have done, we have used URL parse method from URL library, and again we are creating one function. So if it is matches with the particular pattern of the host name, then we are returning 1, or else we are returning 0. That is no abnormal. Now the third is also very interesting library, that is Google Search Python. This library is basically used for finding whether particular website or URL is Google indexed or not. So if it is Google indexed, then it is quite a relief that it may or may not be malicious. But if it is indexed, then the chances of maliciousness will be lesser. Okay. Uh, so for this, we have to import search method from Google search, and again we are simply passing it into search the URL and the 5 as the parameter, and it will return 1 if it finds the URL within the Google search index, and 0 if it. Now comes another important lexical feature, that how many dots the URL have. So mostly we found that if there is a very long URL or malicious type of URL, it may contain multiple dots within the URL. So that's why we are creating this feature. So it will tell that whether count, what is the count of dots. So after creating this feature, you can see that this is the data frame which looks like. Now next move towards another feature, that is count WW. So we are counting how many WWs are occurring within the URL. Similarly, how many @rates are coming within the URL, right? Then we have a number of directories. So number of directories is something, number of forward slashes within the URL. So as you can see that here, where whatever the URL we have, if we have like this https www.facebook.com pages stuff slash. So here you can see that 1, 2, 3. So we have 3 directories, right? Because the number of forward slashes tells us the number of directories within the. Similarly, number of embed. So how many embeddings or embed things we have within the URL? We can find that by counting double forward slashes. Okay. Next comes the shortening service. So we know that whenever we have very long URL, so we use some very popular shortening services which shorten the URLs, which will be easier for sharing to friends or colleagues or different members of groups. So, but sometimes these shortening services hackers also use to share those URLs so that the unsuspected user doesn't understand what this URL is all about. So sometimes hackers also use it. So there are some very popular shortening services we know, that is Bitly, Google shortening services and all. So tiny URL. So we are actually searching all the possible and important, or you can say popular shortening services, URL shortening services. If it is present within the raw URL, then it is a means then it is a shortened URL. So now comes another features, that is HTTPS and HTTP. HTTPS and HTTP. So this will basically tell, because we know that whenever we have a secure site, we have a symbol of secure, right? Which tells that it is using HTTPS protocol. But nowadays hackers are getting smarter, and they are also purchasing HTTPS, that is security certificate, for making their URLs secure, look secure. So that's why we want to see what is the distribution of HTTPS URLs within the malicious. And HTTP, if it is HTTP, then there may be a good chances of being malicious, because nowadays good sites or prominent sites use HTTPS. Now another lexical feature is what is the count of percent within the URL. So percent usually comes when we have spaces within the URL. So spaces are usually stuffed with percent sign. Next, the question marks. So question marks usually tells that what is the ID of particular page or something. So that is also we are counting how many question mark present within the URL. Next comes the hyphen. So how many hyphen equal to. And now the important part, what is the URL length? So if it is a very big URL, then there is a good chance maybe that it may be a malicious URL. So that's why we are taking the length of the URLs. Host name length. So as I told you, host name is something that is the actual domain, you can say, which usually people remember while opening the websites. So host name length, we are finding to see what is the distribution of malicious URL in the host and what is the host name length of those malicious URLs. Now comes another important feature, that is suspicious words. So suspicious words are something that is including transaction or bank payment related keywords, because usually we know that in phishing URLs usually comes with sharing your financial details or something, like your credit card is blocked or something. So in that case, these types of keywords may be stuffed within the URL, and we may sometimes overlook that and just open it. So that's why we are also checking if these types of words present within the URL or not. Next comes another two features, that is digit count and letter count. So what is the count of digits? What is the count of letters within the raw URL? So after creating these features, we see that we have a data set which is looking like this, right? 0, 1 mostly, and some of them are related to length. Okay. So now comes another important library, that is TLD. So you have to install pip install TLD, which is top level directory. So for finding top level directory, we have to parse the URL. Okay, so what we are doing in this feature is basically we are finding what is the first directory length. So whatever is coming before, you can say first directory, it is a first directory length. So we have to pass the URL, raw URL within URL parse method and get the path of it, so that it will return the full path of the URL. And then we are taking only the part which is which is before the first forward slash. Okay. Now comes another one, that is length of top level domain. So top level domain, as I told you, that is something .com, okay, .eu, .edu, something like that. So these are basically top level domain which tells the nature of the website. So for that, we have to extract the top level domain from the URL, and for that we are just simply passing the URL within the get TLD function. Okay, and from there we are getting the top level domain, and from there we are basically returning the length of top level domains. So these are our main features. Okay, so now we have to drop certain unused features, that is TLD. TLD is of no valid feature in it, because we only want numeric features, so we have to delete this. And later we'll also drop URL, because URL is something non-numeric also. So now we have next step, that is EDA. So now we have to see whatever the features we have created. Okay, what is the distribution of different classes within those features? Okay, or we have built good features or not, which are more predictive in nature. So for this we have to do some EDA. So first one, we have to see what is the distribution of use of IP address. So here we can see that only malwares contains IP address, else don't have IP addresses. So it is a very good distinction. Okay, so if we have an IP address, then we should be very aware or very careful that it may be a malware. Next comes the abnormal URL. So for abnormal URL, we can see that we have a defacement as the most highest abnormal URLs. Okay, that's quite interesting. Whereas other have significantly similar number or frequency of abnormal URLs. So next comes another important feature, that is Google Index. So this is a very interesting pattern, that all the URLs in the different categories have are actually basically Google index. So no URL is not Google index basically, and all URLs are basically Google index. So now we can say that hackers are getting smarter nowadays. Next comes another important feature, that is URL shortening service. So as you can see that larger number belongs to short URLs, okay, to the benign or safe URLs basically. So safe URLs are pretty common and they use generally short URL services, while defacement and phishings are relatively lesser, quite lesser, but they still use. But in malware, we have no shortening services. So it may contain some malware keywords. Next comes the suspicious URL. So this is also the same pattern you can see here, as we have uh, shortening URL. Okay, so but we have a good amount of phishing URLs frequency in comparison to shortening URL, but benign have larger frequency. The reason behind that is that we usually the transactions or genuine transactions or banking related websites have these keywords. So that's why benign URLs have more frequency of these types of keywords, while phishing's is the second highest. So now comes the dots. How many dots we have in raw URLs? So we can see that malware URLs have higher number of dots generally within the malware URL, while others have relatively lesser with some outliers. And if we see count of www, so we know that nowadays www is pretty uncommon, and usually people write actual domain just after HTTPS and we'll get the website. So www is now pretty uncommon nowadays. So we can see that we can easily identify that only phishing and defacement URLs have more number of www, while others, benign and malwares, have usually no wwws and very less. So at the rate have pretty common with some outliers, mostly in benign and phishing. Next comes the count of directory. So count of directory, we can see that if we have a good number of directories, so phishing and benigns have relatively similar distribution, while defacement and malwares have relatively less distribution of count of directories. So host name length. Host name length is, we can see, highest in case of defacement, the higher frequency observed in case of defacement and malwares, whereas phishing also have a lower frequency. But yes, if we have a good amount of length of host name, then we should be very careful that it is a type of malicious URL. So now comes the first directory length. So first directory length, we can see there is no significant distribution, whereas phishings and benign have some distribution, while some distribution also observed in malware. So now comes another interesting feature, that is top level domain length. So top level domain length is pretty higher in case of, you can see, phishing, malware and defacement, whereas benign have significantly lesser top level domain, because we know that top level domains, something like .com, .eu, .edu, .org, these are pretty less in length, while if we have a very larger length, then there may be a chance that it may be a malicious. So next step is we have to target label encode our target variable, that is type variable. So for that we are using label encoding to encode the values which are in string format into which are actually categorical variables into 0, 1, 2, 3. Okay. So now next what we have to do, basically we have to create features and targets. So here we are selecting or filtering out certain non-important features. That is, we are not using raw URL, which is of no use. We are only using the features. Second is the Google index. So as I told you in our distribution of Google index, all the URLs have one value of Google index. So it is not adding any important uh, uh, functionality within our machine learning model, because all the four features, or you can say target variables, have only one value, which is not adding any value to our model. Okay, so that's why we are just filtering out Google index. So now we can see that we have 21 features actually. Okay, uh, and by excluding target variable. So now we are splitting. We have to split the training data into our data into training and test set, and for that we are using train test split. So 80% we will be using for training our model, and 20% will be used for testing our model. So two more important parameters we are using here. The first is stratify, which will do the splitting in a more balanced way, in equal proportions. Okay, because we know that our distribution of target variables is not balanced. So we have more number of benign URLs, whereas less number of other categories. So it is very important during the splitting, we should have equal distribution, or maybe balanced distribution for all the four categorical variables. So that's why we are using stratification for that. And then we are also shuffling, so that it should not consider any sequential pattern or something. It should add some randomness within our splitting data. So next comes the very important part, that is model building. So first of all, we are building random forest model, and we are considering it as our base model, because it is more basic model in terms of tree-based models. And later on, we'll be using XGBoost and LightGBM, which are more advanced models in terms of tree-based category or ensemble based. So here we are using very default parameters, just only one extra parameter, that is max features is equal to SQRT, whereas estimators we are using only 100. So you can do experiment or maybe hyper tune your model with different types of parameters. Okay, but for demo purpose we are only using these two parameters. So as you can see, the classification report, we have good detection rate. So we are only right now I'm only considering recall. So you can see that benigns have 98% of recall, whereas defacement has 99%, phishing 94%, malware 86%. Whereas accuracy, if we see, 96.6 is the overall accuracy of our random forest, which is pretty good. And in terms of confusion matrix, we can see that we have around 84,333 records correctly classified, whereas defacement 19,000, phishing 6,000, and malware 16,000. So next we are also plotting the feature importance. So we can see that here we have top features, you can see, which are more heavily contributing towards our model's prediction. So top 5 feature, you can see the host name length, count directory, count www, first directory length, and URL length. So these are the very important features which are contributing in predicting malicious URLs. Next comes another model, which is the advanced model, advanced tree-based ensemble model, that is LightGBM classifier. It is boosting ensemble model. And here we have to pass certain parameters like objective, multi-class, boosting type, GPTT, and we are also providing some randomness within our model. So here if we see, we have a slightly lesser accuracy in comparison to random forest, that is 95.9. Whereas if we see the detection rate, so benign has relatively higher detection rate, 1%, that's 99%. Defacement also 99%. But phishing and malware has relatively lower detection rate in comparison to random forest, which is 94 and 86. Here we have 91 and 83. So that's why the overall accuracy reduced to 95.9%. Or if we see the confusion matrix, so we have lesser malwares. In random we have 16,000 something. Here we have 6,000 something, but here the detection rate is quite reduced. Okay, so it's just a important note that here also we are using only certain hyperparameters. You can definitely use different hyperparameters, tune them so that the accuracy may increase up to more to 3%. Okay, so that you can do at your end. So now if we see the feature importance, so feature importance in that we have FD length, host name length, count directory, count digit, and URL length. So we can see that URL length, count directory, FD length, and host name length have common feature importance in with this one, random forest, right? FD length, URL length, count directory, and host name. Okay. So now comes another third model, that is XGBoost classifier. It is another boosting based ensemble model. And here we can see that our accuracy is somewhat higher than LightGBM, that is 96.2%. Whereas in comparison to LightGBM, we have only one improvement, that phishing is increased from 91 to 92%. Else everything is similar to LightGBM, while malware is relatively lesser in comparison to random forest. In random forest, we have 86%, but here we have 83%. So confusion matrix, we can also observe that we have higher detection rate, 84,000 something, 19,000, which is also similar to LightGBM and random forest, but this is reduced and this is also reduced in comparison to random. So this is the model evaluation part we have, where we have evaluated our. So last is our feature importance of XGBoost. So host name length here is the only common, right, and this use of IP. So these are the only common features. Rest are not common with random forest. So this is the overall distribution of important features. Now the important part, we have built the model, but if we are not able to predict something on real time basis, so there is no use of building that. So for this purpose, we are building one prediction function in which we are basically creating the lexical features from the raw URLs. And for that, we are actually creating one list in which we are appending the results of all the functions. So we have to basically pass the URL, and one by one we have to pass the URL within the functions, and in that order, in which order we have a data frame for that. Okay. So like that, we are passing the URLs within this and appending all the results in this list. Okay. And later on in get prediction from URL method, what we are doing is basically we are creating feature test as a list, accepting the list from bypassing test URL the main function. So you'll get the list, and we are converting the list into an array format and reshaping into 1 into -1, because we need into 2D array. Right? So next, what we are doing is we are basically using here LGB to just check whether it is behaving perfectly or not. So whatever predictions we have, we are just taking it within the pred variable and checking whether its value is 0, 1, 2, 3. And based on that, we are assigning the variable as safe, defacement, phishing, and so this is the testing of the raw URLs. So we have created one list where we have passed 2 sample URLs, and we passed within this function. Okay, and we can see that we have result of malware and safe. So first one is the malware, right, and second, which is a genuine website, Wikipedia website, is predicted as safe. So thanks guys, I hope you like our video of this malicious URL detection, and you can also visit our website, that is wisdomml.in, okay, where we have a complete write-up of this malicious URL detection project, and we have a full explanation of all the steps and a complete write-up, and we have also given the code here. Okay, so you can see the whole notebook and the form of explanation, and we have also provided our Git repo if you want to see the repo of our malicious URL prediction project. So that's it, guys. Thanks for watching our video, and please stay connected to our channels because we will be adding some more interesting projects in NLP, computer vision, and machine learning. Thanks, guys. Thanks for watching our video. Have a good day.